Alright, in this video we're going to go through the 2.7, 2.10 derivatives or DeltaMath assignment for exponential and logarithmic derivatives. So I'm just going to go through and do some examples of each one. Okay, so it says find the derivative of e to the 9x to the 5th plus 9x to the 4th. So this will be some chain rule because we have an outer function that is e to the x, and the inner function is 9x to the 5th plus 9x to the 4th. Derivative of your outer function, e to the x is e to the x. Derivative of 9x 5th plus 9x to the 4th would be 45x to the 4th plus 36x to the 3rd. Derivative of the outside, keep my inside the same, times derivative of the inside. So we get e to the 9x to the 5th plus 9x to the 4th times 45x to the 4th plus 36x to the 3rd. And you can put that in front too, I usually do. Oh no, what's happening here? There we go. Oh, see, they put it behind. We can do the same thing for this one. So your outer function is e to the x, derivative is e to the x. Inner function is 7x to the 6th, so the derivative of that would be 42x to the 5th. Derivative of the outside, keep my inside the same, times the derivative of the inside. E to the 7x to the 6th times 42x to the 5th. Derivative of the outside, keep my inside the same, times the derivative of the inside. Boom. All right, let's go to the derivative of the bases that are not e. So basically this is just, do you know your exponential and log derivatives well enough to be able to do this? You're almost always going to involve chain rule in some way. So we have 7 to the negative 8x to the 6th plus 7x to the 5th. So your outside function is a 7 to the x power, and your inside function is negative 8x to the 6th plus 7x to the 5th. So for these problems, you just have to know the derivative of, we call it a to the x, where a is some constant. That's not e. The derivative of that would be 7 to the x natural log of 7. And then you can still find the derivative of your inside like a normal person. Derivative of the outside, keep my inside the same, times the derivative of the inside. So 7 to the negative 8x to the 6th plus 7x to the 5th times the natural log of 7 times negative 48x to the 5th plus 35x to the 4th. And we can type that all in. So 7 to the I'm going to put a times there just in case. Woohoo! All right, so that's how those problems go. You just have to remember that the derivative of e to the x is e to the x, but the derivative of anything else to the x power is that same thing times natural log of the base. All right, derivative of natural log, speaking of natural logs. All right, so my outside function is natural log of x. My inside function is x to the 4th. Derivative of the outside is 1 over x. Derivative of the inside is 4x cubed. This is one of the ones you have to memorize. Bloop. Derivative of the outside, keep my inside the same, times the derivative of the inside. These ones can usually simplify a lot. So this one would end up being just 4 over x actually, right? Because I have 3 x's on top, 1 x on bottom. Boom. Or you could leave it like that too. Those are your natural log ones. Not too hard. All right, derivative of a regular logarithm. So this one, you have to know log base 6 of x, its derivative. So the derivative of log base 6 of x is very similar to our natural log one, but it's 1 over x ln of your base. And then the derivative of this would be 12x to the third plus 12x squared. Derivative of the outside, keep my inside the same, times the derivative of the inside. So 1 over 3x to the fourth plus 4x cubed ln 6 times 12x cubed plus 12x squared. So you can write it just like that, or I can move that 12 stuff up top. So 12x cubed plus 12x squared. All of that stuff divided by 3x to the fourth plus 4x cubed ln 6. Voila. So that's your log with bases that aren't, it's not a natural log, right? Log base 6, log base 8, log base anything else. So those four are basically just practicing like with basic chain rule and your exponential and logarithmic derivatives.